This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Welcome to this episode of SE Radio. I'm sitting here with Stefan Tilkov. So Stefan, can you say a few words about yourself and what you do?
Sure. So as you said, my name is Stefan. I'm with a company called InnoQ, which is a consulting company in Germany and Switzerland. And I like to say that I split my work about halfway between doing managerial stuff, administrative stuff that's no fun, and the other half is just fun. So this is part of the fun things that I do. I consult with customers still. I do some workshops. I do trainings, and I occasionally write articles and do presentations. And my main topic is architecture. And some people know me because I am a long-time proponent of the REST architectural style, but I don't think that's what we're going to talk about today, as far as I understood you.
Right, yeah. So the reason why I really wanted to do this interview with you is because you're suggesting some, I think, pretty interesting new approaches to software architecture. The first obvious question is, of course, why would you need a new approach towards software architecture? So what has changed, and why can't we go on as we've done in the past?
So maybe a good thing first to say is that, of course, I'm not suggesting that I have the answer to everything, and then
right.
Just do things the way I suggest you do them, and then everything's fine. First of all, there's a certain domain that I'm talking about, which is the typical enterprise software architecture domain. So.
Right.
I have no idea how to do things in embedded systems. I wouldn't know how to do that. So, and I'm not really talking about standalone software the way you'd write a word processor or something. I'm really talking about big enterprisey or enterprise systems. And I think the lessons that we can, there are lots of lessons that we can draw from the way people are building stuff for e-commerce, for internet systems. The big guys used to be the small guys. It used to be that when you were an enterprise guy, as both of us are, then we were kind of the people who build the real systems, while the people who built stuff on the internet were, building simplistic stuff that wasn't really enterprise scale or enterprise grade. Now it's totally reversed. Now the most interesting systems, and the systems that have the largest scale and that are the most impressive in terms of non-functional requirements, at least, are those built on the internet. No company can even remotely approach the number of users that Facebook supports, or Twitter or Google, whoever. On the other hand, we're still building stuff in a way that has been evangelized almost 2 decades ago. So we're building stuff with an architecture that says we have this thing in the middle called an application server. We have a 3-tiered architecture. We have a web tier, and we have an application tier, and we have a database tier. And that's basically just one line that you can draw from, and there's just this one big database down there, and there's this greatly scalable application server in the middle that will handle all your problems for you. And there are so many things. If you look at the old architecture diagrams, maybe we can put a link into the show notes. If we look at those old architecture diagrams from J2EE,
right.
I really mean J2E, not really Java E. So J2E, the original EJB thingy, then there were so many ideas that seem so enterprisey from today's perspective, right? You have those roles that collaborate to build an enterprise system. Somebody builds a component, and somebody assembles those components into something bigger, and then somebody else actually configures and installs the application server, and a 4th person deploys the assembled application into that container. That's a model that is really it's maybe not that popularized anymore, but it's still ingrained in the stuff that we do. People still think that way. People still, at least in many enterprises I deal with, think that way. And it doesn't really matter whether they're using EJB or not. That's not the point, right? It's about an approach. It's about an understanding of what architecture should be like that is very much tied to this particular model. And that's what I think it has to change, because we're seeing lots of benefits from a different approach.
Okay, so basically what you're saying is that the traditional way of building enterprise software, and I mean, you're totally right, that is basically based on the ideas that Corba introduced, that we should change that to a different model. However, what's the real problem with the current approach? I mean, people are out there building enterprise software using exactly that approach, and there are quite a few projects that actually really succeed and are deliver the software that is requested from them. So why would I change it? I mean, where's the breaking point that makes us look for alternatives?
Well, first of all, if you're happy with your architecture, if everybody you're delivering software to is happy, then why would you want to change anything? I'm not suggesting to change anything for the sake of the architectural style itself. That would be stupid. So I'm absolutely sure, and I know from personal experience, that it's entirely possible to build successful systems with EJB 1.1. It's not that would not be the technology that I would select today. At least I'd pick EJB 3 dot something, at the very least. But it's absolutely possible to do that. But there are some problems that I see that seem to suggest that the solutions that work on the internet might actually work in the enterprise as well. So some examples. One would be the time to market that you typically have, the time it takes to introduce a new feature. I have yet to find a successful company with a big system that is not unhappy with the time it takes to put something new into production. It takes ages. Ages in turn, again, you can see the difference in mindset, right? If you approach this from a traditional perspective, then maybe 4 releases per year, or 6 if you're really fancy. That's amazing. I mean, wow, I'm impressed. You can do 6 releases every 2 months. There's a new version. If you view this from an internet perspective, from the perspective of a software as a service company or a social network, that's ridiculous. How can you possibly do that? Now those things merge. I'm not suggesting every company now has its own internal social network, although maybe they should have. But what's changing is that most of the times those boundaries disappear. Your system is on the internet whether you want it or not, and the time that people expect from you is determined by what they're used to, right? Similar, you could actually make a comparison similar to the way that people got used to using computers at home and then expected computers at work to work the same way. They now expect applications at work to be as efficient as the stuff that they use when they interact with their peers on a social network, right? So why would you be happy with an application that takes ages compared to the stuff that you use for private purposes? That doesn't seem right. So time to market, I think, is a very critical thing. The other one is, and that is maybe the one you hinted at the beginning, is that of course, as more and more systems become connected to the net and become open to the world, right? Even if you're a conservative insurance company, you want to have your products accessible to people who want to inquire whether you're a good a vendor for them. Even then, you're putting your stuff on the internet. You have to deal with the scale that people, well, hopefully you have to deal with the kind of scale that people expect there. So many of the things that make it worthwhile to do things differently on the internet are also very much worth doing them differently within the enterprise. At least that's my conviction.
Okay, so I think it's interesting to note that the distinction between enterprise applications and web applications more or less seem to blur.
Let me maybe add something there. A long time ago, I found some posts and they resonated with me very, very strongly. For example, one was from a guy called Dare Obasanjo, who is with Microsoft, who said, "My internet is bigger than your enterprise." And that's kind of the idea, right? We see so much stuff on the net that works there. And another thing that I've said since then, and I don't know where I stole that from, but it's probably by somebody else, I don't know, is that if you look at the way things are done on the internet, they're mostly done in a certain way because there are so many collaborating parties that in an anarchic way somehow have to come to agreement and do things. And that's actually what most companies resemble as well. So while we have the illusion that a company is a very well-organized thing with strict rules from top to bottom and very clear command and control structures, that's typically not the case at all, right? So I think that's another reason we see stuff merging there.
Yeah, and that is also, I understand why you suggest REST as an system for integration, because it's really the system that is used in the web for integration, and it should work in the enterprise as well.
Very much so, yes.
Okay, I see. So So we've seen why you would need a new approach. We've seen what the old approach is, what the drawbacks are. So of course the question is, what is the new approach? How is it different? What are the technological foundations of that approach, and how is that going to work?
So there are a number of things. It's not as if I have a replacement in store that is called J3E or whatever. It's more a set of best practices and stuff that has seemed to work well, and it's not been invented by me in any. It's something that you can observe in the systems that are being built today. So I think the first one, probably the most important one, is that what we're seeing are smaller applications. I think almost every problem in software architecture, not everything, but lots of problems at least, the vast majority of problems at least, can be connected to the fact that we're building systems that are too big. And that's usually not something we want to do. I always ask people, how many lines of code does your system have? And they tell me something like 3 million, 4 million, 5, 7, 10, whatever. And if you ask them, well, did you want your system to be 10 million lines of code? You'll find nobody who'll say yes. Nobody wants that, right? It happens.
Right, yeah.
The system grows. It's successful. That's also a thing. All successful applications have an architecture that sucks. That's a stupid thing to say. Of course, the architecture is obviously good enough, otherwise the system wouldn't be successful. But they sort of suffer from the fact that they had to grow to adapt to their users' requirements. Right? People like the system, so they want it to do more, so it does more, and that's always has higher priority than the other stuff. So we built those big monoliths, and monoliths are extremely hard to change. They're extremely hard to move forward. They're extremely hard to release often. They're very hard to change architecturally or modernize in any way. So I think that's a strong tendency. Of course, you can make the analogy with the Unix model, right? Small, lightweight, focused applications that are connected to something. That analogy works to a certain degree, not 100%, but to a certain degree. But I think it shows that this is really an old thing that people have been doing for a long, long time, right? You have a small thing, the smaller, the better. And if you have a small thing, if you have a system of systems, right, a system that is composed of many small systems, then you still have the whole solution, still have the big thing, because maybe what you need to build is a big thing, right? But it's composed of smaller things that are isolated in a way that it allows you to modernize them and to evolve them and to release them in a different fashion. Those things are something different than components. They're something different than objects. They're something different from libraries. It's not the same thing. I'm really talking about systems that are isolated. So, for example, you could imagine each of those small systems as being a complete application with all its layers, with everything in it, a complete solution from top to bottom, and then you have many of those that build the whole system that you need to support, which is essentially what's been shown to work, because no company these days has a single application. They all have more than one. They have a dozen, 2 dozen, 200 applications, but they're still too big.
So what you're saying is that each of those applications would potentially have its own user interface, for example, or...
That's a good point. So there's an interesting discussion going on there. Maybe we can come to that later if we can contrast that to other approaches. In my view, yes, I very much appreciate if they all have their own user interface, but that's by no means the only way you can build things. And that's maybe something we can postpone a bit.
And are there any? I mean, what would the the foundation be? Which kind of frameworks? Which kind of communication?
Right.
Are those systems, processes on their own?
Yeah, very excellent question. So that's actually the next key thing in my view, which is that the number of assumptions that you have about how those systems are built should be as low as possible.
Okay.
That may differ from company to company. So maybe in one company, the only restriction given is that it runs on a Linux system, or it runs in some sort of VM. Right. That's the only restriction, and it listens on a number of ports, and it supports a certain kind of user interaction via the web or something like that. Those could be the rules, and then everyone's free to build stuff in whatever manner they see fit, which seems like chaos to many people, and I understand that. So maybe you want to limit the degrees of freedom that people have, right? Maybe you want to say, okay, you can just use this one programming language, or maybe you can pick one of those three. you can maybe reduce the number, right? You give people options to choose from, and you manage the set of options, but you give them a smaller surface of rules that you'd give them in a traditional environment. Compare that to, say, the EJB model, right? The EJB model also has this idea of isolation. You have those isolated things, those on various levels, right? You have an EJB, and then you have an EJB jar, which combines EJBs into something, and then you can connect those EJB jars to other EJB jars by means of configuration in your deployment descriptors or your settings in the container, whatever. But there is a lot of assumption. Everyone has to build their stuff in Java. Everyone has to build them as EJBs. Everyone has to build them using the same Java version, compatible with the same application container, all at the same time. They all have to run in the same container. They all have to communicate using RMI. So there's a huge number of assumptions in there, right? It's not as if you could decide to rip out one component and build it using Node.js, because that violates the original assumption in there, right? So that it plays a distinct role there.
Yeah, but I mean, if you look at it, a system that just runs on a limited technology stack, it's obviously easier to implement because there is just less technologies that you need to know. It's easier for people to get to know new projects and work with them. And it's also easier for operations because they are limited to a certain technology stack. So there seem to be some drawbacks. So why would I do it?
It's an excellent question. Of course, it's potentially more complicated, right? I mean, you could choose to build stuff this way and still use the same technology in every system. You can do that. That would be totally be an option. It would still be more complicated because if you have separate systems, then they have to communicate in a cross-system way. They would have to use some messaging system, or they'd have to use HTTP or Carba, whatever. It doesn't really matter. They have to use some technology that will probably be a lot more complicated than if you just build a single system. So that's the first investment you make. You say, okay, I'm investing this because I want to have those isolated systems, and I want to be able to reap the long-term benefits of having separate systems because I can evolve them differently. Now that is probably the main distinction here. It's fine to have a single technology stack. You still have drawbacks there. If you pick a single stack, then maybe it's not the optimal one for each system, right? So maybe this system should have been built, or would have better built using C++ or Node.js or Erlang or Clojure, I don't know, whatever. And this one should really have been a C# based system. And this one, of course, Java, whatever, right? It's as though you're limiting your choices, but I understand that's a trade-off that you might want to make there. But far more importantly, in the future, you can evolve them in the degree of difference that you find acceptable. So maybe it's just that you want to update this system to a new version of Java, and you're not updating this one. If you have this single monolith, then every decision affects everything, right? You want to move to a new version, that means everybody has to move to a new version. If you have a 100-person team, and that's not a rare thing, right? If you have a 100-person team, then you have to synchronize that 100-person team to move to a new version of anything. The cost of that, and the risk associated with that, and the effect it has on the day-to-day work of evolving the system from a functional perspective is tremendous. You just how would you ever convince management of doing that, right? That's the main reason why systems that have been built a decade ago, 15 years ago, very often these days are still suffering from the same architectural choices. They were good back then, or they were justifiable back then, but they really hurt you today because it's stupid to have a system with its own custom persistence layer, right? You have 500,000 lines of code of some Java 1.2 compatible OR mapper that you wrote in-house. That's a tremendous cost, but you cannot move away from it because you just can't move the whole application there, right? That would be a good example of something that we see customers suffer from.
Okay. Would you, I mean, there is this other trend, DevOps, and having teams that operate the services as well as develop them. So would you suggest to use this concept in DevOps environment, or only in a DevOps environment, or? Well,
it's, again, very good question. I think it's an excellent match. It obviously matches this idea, right? So you have this small thing. Now, if you have those smaller systems, it's a very obvious thing to say, well, this team is responsible for this small thing. And now, if it's a small thing, then maybe they can be responsible not only for developing it, but also for deploying it, right? That would be that would be a useful thing to do. Now, the connection doesn't have to be mandatory, right? You don't have to do DevOps to do that. I think it helps a lot. I think it makes a lot of sense because you can then evolve those systems in terms of what is actually deployed, right? What you can do is you can have your teams deploy a new version of a single system that just does one specific thing, as opposed to having everything deployed at once, which is one of the reasons why people only manage to get these very few releases per year, right? If you look at a big insurance company that has, I don't know, some policy administration system, those things are huge. They're beasts, right? And they have a testing and deployment cycle that requires a month, even if you haven't changed much, right? It's always the same fixed amount of time that you have to invest to get this thing into production. So obviously you cannot do that 12 times per year because you would only be deploying, you'd never be developing anything, right? It's really hard to do that. And what we of course like in a DevOps environment is to be able to deploy tens or dozens or hundreds of times per day, as opposed to 4 times per year, which seems, if you talk to a typical enterprise person, that seems like a totally ridiculous notion, deploying multiple times per year, per day, if they're used to deploying multiple times per year.
Right. But if you end up with a system where you have a lot of smaller systems talking to each other, doesn't that mean that you're pushing the complexity up to the next level, to the level where systems talk to each other, and then you end up with chaos and challenges on that level?
Well, it's an interesting discussion to decide upon the number of systems that you want to have, right? Do we want to have, which I would consider something like a nano services approach, right? The smallest amount is just 100 lines of code per system. It just does one thing. It does nothing but, I don't know, check whether a number is a valid customer number, customer key.
Right.
That will be one function, and this system does just this one function. I think that's a possible approach. Theoretically, I've never seen it work. I can't claim that I've seen it fail on a large scale, but I have strong doubts that this is a good idea, because if you end up with thousands of systems, I don't think you're helping yourself, right? I think if you have a reasonable number, and of course reasonable is a Weasley term. So let's say if you have something between maybe 5 or 20 systems in somewhat significantly large context, that feels like a good number to me. And those systems would be bigger than just a single function. They would encapsulate a bunch of consistent logic that actually makes sense to be used on its own. That would be my preferred way to approach this. That's an interesting discussion in terms of this microservices idea, which I'm sure you'll be getting at some point during this conversation. Right?
Yeah, actually, that is what I wanted to ask next, because you already talked about nano services, and if what you gave as a definition of such nano services is actually what some people suggest as microservices, really small services, just 100 lines of code. And they claim that you can build systems based on that. So I was wondering how your idea and your approach compares to that, or how that is different.
So I think there are a lot of similarities. That's the first thing. And I'm not sure the approach I'm suggesting is not actually the microservices approach. I don't know. I don't think the microservices people know either. I've conversed with some of them. This is a very fresh thing. So microservices, as I understand them, and as Martin Fowler defines them in his article, are reusable small things that do one thing well, that are focused and lightweight. That is pretty much in line with what I suggested. I think it's also commonly agreed upon that these things are communicate over the network and somewhat service or SOA-like, right? A lot of people I know from when I was very, very active in the SOA community argue that microservices are nothing but SOA. It's the same thing. There's no service-oriented architecture, right? No difference at all. Microservices are just the way people have been arguing SOA should be done in the first place, before SOA became tainted with major vendors pushing their enterprise service buses. So that's another distinction as well. So I think from that regard, or from that view, that is very largely the same thing. I think there are two possible differences. One is the size, as you mentioned. I don't think there has been agreement yet in the microservices community. This definition that you mentioned, a few hundred lines of code, I've seen that, but I've also seen it contested. I've seen people who argue that a microservice doesn't have to be this small to be a microservice. It just has to be an individually usable thing. So James Lewis, who co-authored the article with Martin Fowler, argued that it would be a reasonably coherent, consistent kind of thing. I don't think he mentioned this 100-line kind of thing. that is, I think, a potential difference. So in my view, the things that I'm talking about, that I don't really have a name for yet, I'm open to suggestions, is definitely bigger than a few hundred lines. That would be a very rare exception. The more important difference in my view, again, I'm not sure whether it's a difference, I pose it as a potential difference, is that as far as I understand the microservices approach, it's really a service. It has an interface that's invocable over the net, so you can put a request to it, get back a response, maybe sync, maybe async, whatever, right? But it's sort of a dark thing. It doesn't have a UI. In my view, the thing we're talking about should have a UI, at least in the majority of cases. So that's a different thing. I'm not suggesting what I don't like as an approach is having a front-end application, that actually invokes lots of services, because I think we're then making a strong mistake. I think the UI is a very important part of the service. If we don't make it a part of the service, then we are under the illusion that the UI isn't that important, because we're not addressing that. We're just addressing the back-end stuff. I think that's a common mistake. And of course, this is true as well for the lower layers. So I think the database, the status that the service has, I think services should have status inside of them, should be part of this system. That's why I say system, not service, right? They should be a system, because they should have their own persistence, they should have their own logic, they should have their own UI. It's a complete and consistent thing that, of course, talks to the others, but is self-consistent in something of its own. Now, again, that's not I wouldn't say that this is a major trend or anything. It's something I've seen work, but I do think the architectural approaches that we see coming up these days all share this trait of having smaller things that are technology independent and that are run separately from the others with potentially different implementation technology. Could be the same, but doesn't have to be the same. I think that's a very critical thing there.
Okay, I see. So you've already talked about SOA and how this compares to this approach. To me, SOA was always about sort of an enterprise strategy to really take all of your IT, separate it in different services, and then somehow get a benefit from that. It seems to me the difference to this new approach is that, in fact, we are just talking about one system that provides one kind of service to some customer that is composed of different services. And this system would somehow be built in one team, not like an SOA in an all-enterprise effort. What do you think about that? Is that a distinction between SOA, or am I getting something wrong here?
I think the nice thing about talking about SOA is that everything we say is right, because nobody has any authority of defining anything, right? Of course, you can make a case that SOA is a company-wide approach to getting your application portfolio architected in a better fashion. Then this discussion is a different one, because it's typically about a system. You could also say that it's just the same thing on a different level of granularity. And if you look at a company that is a website, something like Facebook, where would the difference be? I mean, I'm very sure they have internal payroll applications that are not publicly accessible, but the vast majority of what they do is the system that everybody sees and uses, right? So I'm not sure this is much of a useful distinction. I've also seen people, I've been in so many discussions about what SOA is and is not. I would say that there definitely is a strong case to be made that a lot of those ideas that we now see, specifically in the microservices discussion, have been there in the SOA discussion almost a decade ago. There are lots of people, I can actually link to some blog posts, people arguing almost exactly the same thing. So for me, the major difference is that we're including the UI and we're really talking about a complete application. That's a difference to my own arguments that I used a decade ago. So that would be my major distinction, which is not a distinction the microservices people make at the moment.
Okay, the other thing that comes to my mind, at least, is that we now have a set of services that talk to each other. And I mean, the old first rule of distributed objects is that you shouldn't distribute your objects and you shouldn't have distributed systems. Now, separating services and having them talk to each other over the network seems like a violation of that rule. So
right. So what I'm doing now is hand waving, which is a stupid thing to do on a podcast, but I'll try to convey an image by description. So what people typically think of is they have this monolith, this box, and now when they think of introducing something like services, they make a horizontal line. They cut this box in the middle, right? They cut right through it horizontally. And then they take the lower part and cut it into services vertically. So now you have a block on the top, which is your application. And now you separate out the stuff from this application that's potentially reusable into separate services. And then you have this network interface in there. That's not what I'm talking about. That will not be the approach I'm suggesting. That to me seems like a classical SOA, enterprisey SOA approach.
Right.
The main problem I have with that is that I think traditionally it's the one that has been suggested by back-end architects. I think you're a back-end architect as well, like I am. You're not a UI person. Most architects
in that sense I am.
Right?
Yeah.
There's a strong tendency for that to be true, right? Architects are typically back-end people. And back-end people tend to view the UI as something ridiculously simple and not worth discussing, which is why we end up building those services that are supposed to contain all of the value of the company, the valuable business logic, but very often just end up being anemic, small wrappers around a database. And this UI that we said, that's then easy to build, right? That's you just click a bit and do whatever stuff you do on the UI with your UI tools, and you connect the services. That's going to be easy. The UIs are actually very often what contains the value, right? Because there's so much logic in there. Now again, visualize that monolith, visualize that block that I talked about. What I'm suggesting is that you start by carving vertical lines through that monolith. Now, you don't even need that interface between the front end and the back end. That's not what I'm suggesting. Just make separate, if you want, silos, right? Separate things, separate vertical systems that do their own thing, and connect them as thinly as you can. My favorite way to connect systems, especially if they're web-based systems, is to just introduce a link, right? You have this one application, it has a link to a different application. Now they're connected, right? That's the least coupling you can possibly have between two systems. They don't talk to each other. It's just the user's browser that allows them to get from one system to the other. Now, for that to work, of course, certain things have to be there, right? For example, you have to have a single sign-on mechanism so that you don't have to log on to 20 systems. And the second one is you want those systems to look similar, right? They have to share the same colors and typography and the UI components, maybe, the same visual language so that a user doesn't notice. And if you actually look at systems built these days, Amazon is a good example. If you don't use the Amazon one-click ordering process, but instead go to your cart, right? Then if you look closely, you can see that these are different systems. This looks slightly different. It's not the same thing, but why would you care, right? As a user, you don't care about that. As an architect, you care a lot, because what they've done, what many e-commerce customers actually do is they separate out their stuff this way, and now you have a separate system whose only responsibility is to handle that checkout process.
Okay.
Of course, it has connections to some other systems, sure, but the vast majority of its services, it performs on its own. It has its own UI, it has its own interactions with some backend services, and maybe if you've gone through 10 steps or 7 steps or whatever it is, all of them not offering a back button because you're not supposed to cancel once you started the checkout. Once you arrive at the final step and you do something, they accept the order and persist it, and probably asynchronously notify some other system to actually fulfill it. Right, that would be the view of a system that I think is an interesting view here.
So I browsed through one of your presentations, and one of the things that stuck to my mind is design for replacements instead of reuse. So, and that seems like throwing overboard quite a few things that we're used to.
Yeah. So first of all, let me give credit. That was not my invention. That's a James Lewis phrase. That's one of the guys, as I said, who co-authored the microservices paper with Martin Fowler, and I've heard other people repeat that phrase. But I think it's a good thing, and kudos to James for coining it. I think it's a strong illusion that we're actually achieving the level of reuse that we want, and I think we know that by now in terms of libraries that we build. People have started to accept that. But I think it resonates very strongly with me for this kind of system as well. If you have carved up your system into a system of systems, then each of those systems becomes a separate object of a potential decision, right? You can look at that particular system and you can make an informed decision whether you want to update it, evolve it, or maybe throw it away and build it again. Now, if throwing it away and building it again is an option, then you've done the right thing. So if you build stuff that way, right? If you build it that way, then it's a great thing. You'll very likely not end up replacing everything all the time, but sometimes it's an excellent idea, right? Sometimes you see, well, I have this system now. Let's say it's the registration system, right? That's a good candidate, I guess, for something that you can separate out. Users register on your website. You have some, or on your internal system. They have some flow for them to get notified of forgotten passwords, whatever stuff. That's got nothing to do with the actual functionality of the system, right? It's got nothing to do with you building a social network or an e-commerce shopping site or something. It's just you have to register, right? So that could be a useful thing. If you separate it out, then it also makes it easy to connect it to new business ideas that you have, right? The new product that also shares the same identity with the other products that you have, something like that. And maybe you'll find out that a year from now, you'll have replaced the, I don't know, the database that stores your users, and you now want to only accept Twitter and Facebook and Google logins for some reason. Then you throw away that system and build a new one. Maybe that's a good option. In general, you won't do it, but the fact that you can is what makes a difference.
Yeah, so it decreases the cost of throwing away a certain piece of the software, which probably we should do much more often instead of trying to still make it better.
I fully agree.
It.
Yes.
Yeah. So who is already doing this? I mean, is that something that is brand new and nobody's in fact doing that, or?
No. So if you look at a lot of discussions about big sites being built, specifically those that share their internal architecture, you can see this idea of having smaller systems everywhere. It's at Twitter, it's at Facebook, it's at Amazon. Yeah. There are lots of examples of that, with of course a lot of differences in detail on how they do it. But in general, that's I think something that you can see there as well. Also, I see it personally in a number of projects that I've been involved with, and my focus is mostly Germany and Switzerland, so for our international listeners, that might not be as relevant, but I see it in classical companies, insurance companies, and banks, as well as e-commerce sites, and lots of companies. Groupon is another excellent example, both nationally as well as internationally. There was a good talk by a Groupon CTO that we can also link to in the show notes, and he described exactly this. And their monolith, interestingly enough, was or still is in the US, a Ruby on Rails application, which proves that you can build monoliths in any languages, even in the cool ones, right? It's not the fault of the language; it's a fault of the architecture. So we see that in a lot of places. Again, the degree to which, or the size of the services differ, the exact interfaces differ. There are lots of differences, but this general idea, I think, is really prevalent right now.
Okay, I see. So as we've seen, sort of the old model was sort of incarnated by J2E and Java EE. What is the new technology stack? I mean, what is the influence of this kind of ideas towards the technologies that we should look at and use in our projects?
So one of the things that I see very often combined with this approach is having something that basically is just a process that you start, right? It's something that you should be able to start quickly and remove and shut down quickly, kill quickly if you're following those chaos monkey kind of approaches that Netflix does. Also a good example, by the way. A key idea is that it should be a self-contained thing that you can start and stop, and there are a number of things upcoming. So in the Java world, for example, there's a thing called Drop Wizard, built by Coda Hale. That actually is an assembly of existing libraries, right? There's a JAX-RS library, Jersey, and there's Metrics, which is his own for monitoring, and there's I forgot, Velocity, some template, whatever, some stuff that allows you to quickly build a web-based or RESTful system to do something. And what you do when you use that is, in the end, you produce a single jar that you can start with Java minus jar name. That's it. So it's the exact opposite of the awful container model of the app servers or even the servlet engines, right? It's not as if you install a Tomcat or a JBoss somewhere and then throw applications in there. You install an operating system and then you start processes on there, and maybe your deployment mechanism is something like an RPM or a Debian package, right? So tools like that are a good example. You can see the same idea in Play, which is another Java and Scala-based framework for doing stuff like that. It also is self-contained, also has this idea. But even if you're not looking at frameworks, but rather at approaches, you can see that, for example, in the server-side JavaScript world, by Node.js, there's the tendency to just start a server explicitly, right? You have this main event loop body kind of thing, and then you start start a server register of callback functions to be invoked when that server gets a message. It's not as if you deploy into something existing. You create a program and then you start it using the runtime. So that would all be examples of something that has this self-contained character.
Okay, so this is with regards to implementing the systems themselves and how they are deployed and monitored. So that is one part of the equation. I believe when services talk to each other, I mean, services might fail.
Oh, absolutely.
There are quite a few issues around that. How do you deal with that, and what's the answer there?
Right, that's an obvious point and a good question. Again, a single system should be as independent as possible, but that will only work to a certain degree, right? So at some point in time, one system will talk to another. And depending on your architecture, you might actually end up with a cascade of calls, right? Where you have multiple backend services providing you with data that you aggregate in a front-end kind of system to stream to somebody else, right? That's a very connected thing, and you want that to work and not to fail. And if you increase the number of systems, obviously the potential for failure increases exponentially with that. And that is now, I think, a recognized truth. And you can see more and more approaches to address this. A good start for listeners interested in that is Mike Nygaard's excellent book, Release It. I think everybody should read it twice at least. Great book, great guy. He actually has a very readable, very entertaining book about the pattern, the anti-patterns, the problems, and the patterns for solving those problems, illustrated with a number of wonderful war stories explaining how things went wrong in production. Wonderful book, and he introduces a number of patterns, like for example something called a circuit breaker, which is in software a means for you to find out that, or to actually, if something has failed, stop invoking it over and over again, right? Detecting a failure, then opening that switch and making sure not every call again tries the same stuff. And then after a while, closing it, trying whether it works now, and then, adapting to that. Or other examples, a bulkhead pattern that isolates stuff, right? Instead of having a single thread pool that everybody draws from, you have multiple pools for different purposes, so that if the connections to one system eat up your threads, you have other threads available for talking to other systems, stuff like that. Those are all patterns, and there are now a number of implementations. Hystrix will be a great example, built by Netflix, who have a number of very interesting patterns or libraries, in fact open source libraries for that. And Hystrix actually includes implementations of those patterns in Java, so that you can call a system and code it in a way that failure becomes an expected thing, as opposed to something that's never going to happen. And if so, you just throw an exception and are done with it. So that will be one part. There are other things like, for example, the granddaddy of all fault-tolerant, reliable distributed systems is Erlang, which is a great language, and many people actually use it for that. WhatsApp would be a great example of a very successful thing built in Erlang, and successful not to a large degree, I think, because of the platform's quality. There are implementations like Akka for Scala and Java that embody the same ideas, so that allow you to build your system in terms of independent actors that communicate using messages. That's not the same thing as the system thing we're talking about, right? It's a different layer, it's a different level of granularity, but the models of actually watching a process that you started and restarting it if it fails, and dealing with the failure are embodied there as well. And maybe the last thing that we can mention is we have a number of implementations now of what's called the reactive pattern, which allows you to consume something like maybe an event stream coming from another system and doing stuff with that event stream while facing potential failure, right? So you can program you have a nice programming model that actually makes it easy to aggregate stuff, even if it comes from multiple sources, from multiple systems, and do functional transformations on it and do interesting things, and then create something new with it. As opposed to littering your code with all that failure handling stuff everywhere, right? You get a very nice model of doing that. Again, my preferred way would be not having to do that, Right. My preferred way of systems communicating with each other is not having them communicate at all. If you can get by with that, that's obviously better than the best distributed communication solution that you can come up with. But if you have to communicate, and sometimes you do, then at least use one of those things. At the very least, specify a timeout as opposed to just calling something and hoping it works.
Yeah. Okay. So and I guess in particular for the reactive stuff, it's not just about the asynchronous communication, and therefore it is easier to deal with failure. It's also about the better performance and the better scalability, right? So it's I guess this is just one reason why you would look at these technologies.
I would agree with that. Yes, there are many things interrelated right now. We can make a whole case, including everything from DevOps to architecture to web-based and REST and async as opposed to thread-based, and so many things that cooperate. I think we have a tendency, as we started out with, of having small, efficient systems that scale well, that do real stuff. We didn't talk yet about stuff like, or maybe we won't, stuff like horizontal scaling as opposed to vertical scaling, right? That's another idea that we could address briefly. So the key idea is that as opposed to having that big application server and that red database application cluster that you have below it, you actually scale by duplicating stuff so that you have commodity hardware running those small software parts and forming a whole system of individual systems that are each that don't share anything with each other. So you have this shared nothing approach. That is a all connected, right? It makes it pretty complicated, but these are all maybe not complicated. It makes it a vast field, right? There are so many things that we could talk about in this time, but they're all, I think, related ideas that show that things are changing. That's the feeling I get from the whole discussion at the moment.
Yeah, I couldn't agree more. It seems that there are so many things moving right now that things are really moving in a certain direction, but quite a lot of things are moving. I mean, another example would be NoSQL databases that also somehow fit into this picture because they have a similar approach towards scaling. They also deal with failure in a certain way,
right?
The resilience approach and so on.
Yeah, I
so
agree.
I think that's true. One thing, so I mean, when you really do this, you end up, in particular, also with if you do horizontal scaling, you end up with a lot of machines that run certain things, because now a service or a component is basically just a VM, and I imagine that at one point you will end up with a lot of VMs. So isn't that an issue that is obviously hard to work with, hard to operate, and so on?
Yeah, so maybe that's the third part, right? So we discussed two issues essentially. We said we have to build those smaller things, and then we discussed that we have to connect those smaller things to form larger things more smartly than we did in the past. And I think the last one is exactly what you're addressing. We have to be a lot smarter about putting stuff into production, and we have to cease viewing it as something that is done by different people using a different approach, right? It's actually it doesn't necessarily have to be the team that built the service that does it. So it's maybe not DevOps that I'm talking about here, although that will be a great fit. But I'm definitely talking about a level of automation that makes this a very, very common thing to fire up new machines, to put them down again, to go back to starting configuration. In one project that we've been involved with, we discussed the idea of using the virtual machine as the basic deployment unit. Right, this is the thing that you deliver your software as. You start with an image, or maybe with a script that configures a standard VM to conform to that setup, and you don't set up a root user on that system. There is no way to log on and change something. Why would you want to do that? If it doesn't work, just kill it and start a new one. Right. And if that new one doesn't work either, you probably have to fix something in your deployment process. And if you watch companies, again, a lesson to be learned here, I guess, for enterprise, that we try to apply to enterprise projects. A lesson learned here is if you look at people like Etsy, they're deploying in a so strongly, so highly automated fashion that the one thing that an employee does on their first day is to put something into production. Now imagine that in your typical enterprise company, right? Your first day, you're lucky to have an office and a PC, right? This would mean that you would actually be set up to be able to do that, and that gives you this flexibility, this agility to make lots of changes that are much smaller as opposed to those big releases that have to be tested for years. If you put something into production, it's a small thing, and if it doesn't work, it's just as easy to get it out of production or update it with a solution that requires a significant degree of automation.
Yeah, what I like about this story is also that if the new guy manages to break the production system, it's actually Etsy blaming themselves for making the system so weak that that guy could actually break it.
Exactly. So obviously, I think neither of us are suggesting to relax the rules on testing or on anything like that, on quality, not at all. On the contrary, I think we both believe that quality is going to be a lot higher if you can do that, right? If you go to a typical enterprise company and ask them to, I don't know, look at that cluster, right? It's a database cluster. It's formed of 4 machines now, or maybe an application server cluster built of 4 machines. Do they all share the same configuration? Yes. Well, are you sure? Yes. Really sure? Yes. Okay, let's take a look. And then you take a look and you browse around the file system and you find the remains of some other installation and some parameter that's been configured differently. This is absolutely prevalent. Everybody does that, right? There's no way to avoid that except to forbid people to fiddle around with the machines. They're not supposed to log on. Maybe they can log on to examine something, to find an error, but they should never configure anything by hand. That would be the ideal solution. I think we're approaching that with very fast steps.
Yeah, and also, I mean, it becomes more fashionable to just define a full virtual machine as the thing that is deployed into production. I mean, that's what Docker, for example, does,
right.
And it fits this approach also because then you have these services on your machine, and you have a very simple deployment on your machine, and then you just basically deploy the machine as the software.
Yeah, absolutely agree. Docker is a great example of something that shows how much this idea is becoming widespread. Right, people actually now need a way to run 12 or 24 machines on their laptop, right? So you'll have somebody with a MacBook Air running 24 machines, which are not really machines, but who cares? They share the same characteristics, the same thing, and they are a much closer reflection on what you have in production later than some isolated testing scenario would be.
Okay. Is there anything I should have asked you, I forgot to ask, or anything you still want to mention?
Maybe that one thing that I notice is that very often people think these are ideas that are so far away, so hard to get into their current systems that they just give up. Right? They don't see a way to do that, and I think this is actually a pity, because very often it would just take a few people to just try something out. Right? You don't have to change the world all at once. You can do it one service or one single system at a time, right? And build something that's now new in this fashion. And the difference in productivity is really amazing. It's not a silver bullet, but it really is amazing how far away we are from what's possible in many scenarios.
Yeah, that's a good point, because when talking to you, I was reminded of a consulting gig that I did a few years back, and the idea was to implement new, better stuff in a large legacy system. And at one point, I basically said, well, what you really should do is you should build a separate system and then just limit the communication to links between the new and the old system. I mean, HTML links. And I suggested a shared database in this specific example, which isn't from an architectural perspective the best idea, but was just what could easily be done. And then you already have the first step towards this approach, where you basically say, okay, here is the old system, here's my new system, and they have a very limited means of talking to each other, just links or whatever. And then you can easily build a new system with a new functionality without being tied to all the legacy that you have in your old monolith. So I think
exactly.
Your point is absolutely valid.
It's a great. I think it's a great idea to do this. We've used the same approach in projects. I think the nice thing is that you get very liberated from all the restrictions. You really only notice that once you can start doing that. Many people do that by night, right? By day they'll work on the legacy system with all those rules, and by night they build something else. Now this would actually give you a chance to do the fun work at work, which is the best kind of work that you can have.
I think that's a great way to end this discussion. So thanks a lot for talking to me about this approach. And
thanks for having me.
Great day. Yeah. Okay. Thanks. Bye.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To support us, you can advertise SE Radio by clicking the Dig, Reddit, Delicious, or /dot buttons on the site, or by talking about us on Facebook, Twitter, or your own blog. If you have feedback specific to an episode, please use the commenting feature on the site so that other listeners can respond to your comments as well. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks again for your support.